So before you begin, make sure you take a look at my videos, which was a review of grade 9. Now, you can speed through it as much as you want. Just understand you need to be able to do these. We're talking about the period of functions and how to actually draw them. You're going to be doing the math behind it to find, i.e., the period or find a specific value or a time. That is what we're doing today. Based on the graphing, we should be able to do our calculations. So just quickly watch that. If you understand that stuff from last year about period of sine functions and stuff like that, then you're fine. If not, watch the quick refresher. Other than that, continue with this next lesson. So I need you to find the x-intercept, but I don't want you to graph these at all. Do not graph it. So here's the function. I've got y is equal to sine of x, 3 sine of negative 5x. Now, based on this graph, I could literally say that the amplitude of this graph is 3. So it goes, so its minimum value, and plus 0, plus a 0 vertical shift. So the maximum for this is going to be 0 plus 3, which is 3. And the minimum of this graph is 0 minus 3, which is negative 3. Okay? Now, that is what we get from our amplitude, right? The inside part of this, right, we want to find, I'm going to talk something quickly about this. So now this value here, this represents a stretch, but within a periodic function, what this represents is the period. The period for functions in this type of problem set that we're doing with radians is always going to be 2 pi divided by whatever number sits in front of the x, or whatever. So you're going to get 2 pi over 5. In math, we normally call this the k value in our sinusoidal, tangent, or cosine type functions. And the general form for our period is p is equal to 2 pi over k. So if you're ever looking for the number that sits in front of the x value for a problem, you always do that. Now back to our problem. It's asking us to find the x-intercept, right? So in order to find the x-intercept, what we have to do is we have to let y is equal to 0 in our original equation. So you're going to have 3 sine of negative 5x is equal to 0. Now, when you're solving for this, you're going to end up with, you're going to actually solve for just the sine of negative 5x. So we divide both sides by 3. So now you're left with sine of negative 5 of x is equal to 0. Now you need to ask yourself, when does that ever happen? The only time that happens is if the only time sine happens to be 0 is when, if we were graphing it, it always happens when sine is, in math, you'd always know sine of 0. Sine is always 0 at 180 or 360, right? But this is pi in radians, and this is 2 pi in radians. So you'll notice that it keeps going. So the key idea is, if that actually happens, then we're going to do this. 5x is equal to n pi, where n is an integer. Okay? Now, if that's the case, when we're solving for it, this means that f equals the following. Divide both sides by 5, and you end up with n pi over 5 for n belonging to integers. Okay? And that is our final answer. So the key idea is to find the angles for which all of those things happen. Okay? If you want me to show you a graph of it, we can take a look at that later. So now, let's go on to the next problem. So let's find all the intervals between 0 and 2 pi, and then we're going to find all the intercepts using periodicity. Okay, so here is the concept. You're going to basically let y is equal to 0. So that means you're going to get 0 is equal to 1 minus 2 cosine of x. So that means that 1 is equal to 2 cosine of x. Solve for x, you got cosine of x is equal to 1/2. Now that actually gives us something to go from. So remember that when we had our triangles, our triangle was pi over 6. It had a side of 1 and 2 and root 3. No, this value here in the bottom corner was not 1 over 6. It was pi over 3, which was 60 degrees. And then this was pi over 6 up in the top corner. So now, here's what it tells you. You know that the answer is 1/2. And because it's 1/2, our chart, when we draw it, it's 1/2. So it's going to be 1/2 in the first quadrant, the all quadrant, which means that this is 1. No, that's not 1. That is root 3. And then this is 1. And then in the bottom quadrant, we also have that same problem again. But this time, it's going to be negative root 3 going down, and then a 2 and a 2 here. So now, that gives us these two angles, the angle from here to here, and then the angle from here all the way around, right? Now, those angles between 0 and 2 pi. Remember, 2 pi goes all the way around our circle, okay? So all we need to do is find those two angles. So for cosine of x equaling 1/2, this means that x is equal to 1/3. And I'm going to put that in black. So it's going to be pi over 3 for this angle. Now, the acute angle in the second triangle is also pi over 3. But we have to actually take 2 pi and subtract pi over 3 to get 5 pi over 3. Okay? So the angles are x is equal to pi over 3 and 5 pi over 3. And we are done for those values in our set of points. So here's what we're going to do. We're going to do a problem that asks us to create an equation for this graph, right? Basically, what you need to recognize is that both sine and cosine style graphs have a period which is equal to 2 pi over k, all right? Where this part here in front represents the amplitude, i.e. how high it goes up and how high it goes down for our graphs. Now, we could also add a vertical shift and a horizontal shift, but we'll start with just this. Now, you'll notice that this here is my basic y-axis, right? And because this is a y-axis and it starts above the line when we look at it, we're going to be using this specific graph here. If we have a point, if we have our graph starting at 0, 0, then we would use a sine type function. Now, based on this, you can literally find how high and how low this graph goes, right? This graph goes up to +3 and down to +3. So that means our amplitude is equal to, well, you go 3 minus the bottom and then divide by 2, which gives us an amplitude of 3 for this problem. So now let's figure out the period. So the period is basically going from here to here, i.e., how far do I have to go until it repeats itself again? So in this case, the period is 8 units because it ends at 4 and starts at -4. And we figure out that total distance. Okay, so now here's how we calculate the period and the basic equation. So right now you're going to say y is equal to a cosine of kx. Now you know that your amplitude is 3. We calculated that before. But now we must calculate the period. The period is, well, the period is calculated by this thing here, 2 pi over k. So we go p is equal to 2 pi over k. And what we're looking for is the k value, but we do know the period. The period is 8, and we have 2 pi over k. If you solve for k, you end up with 2 pi over 8, which is really pi over 4. So in this case, the k value is pi over 4. So our final answer is going to be this solution. So the equation is y is equal to 3 cosine of pi over 4x. And we're done. So right now what we're going to do is we're going to figure out how we're going to graph something like this. Y is equal to 5/2 cosine of 4x. So you need to find the amplitude. The amplitude for this problem is going to be 5/2. Okay. Now its shift up and down is 0, and its period is given by 2 pi over k. But the period was actually 4. It's 2 pi over k, but k is 4. So you have 2 pi divided by 4, which is equal to pi over 2. So now what we'll do is we'll quickly sketch our graph. Now, here's what you do. Split your graph up into your x-axis up into 4 parts. Because a parabola, sorry, not a parabola, a sine or a cosine has something that looks like this, or something that looks like this around the x-axis, right? There's always a top and a bottom. There's always like a top, a middle, and a bottom, right? And all of them will interact at certain points, okay? Now, what I'm going to do is I'm going to write everything in terms of fourths. So now you know that if I go from, let's say, -pi over 4 all the way up to pi over 4, what we've just done is we've created a total period of pi over 2. So that's where this comes from. So that's a total distance of pi over 2. So now we have to go and sketch what's happening along the x-axis, sorry, the y-axis. So this is 1, this is 2. 1 and 2, and we'll do the same for the bottom. -1 and -2. Okay, now And we can go up even, no, we can go up a little, no. And now we know that when it starts, our basic cosine looks like this around the x-axis, right? So this is its highest point. So its highest point for this is at 2.5. Right? Now its two endpoints, which are here and here on my graph, are going to be at its two lowest points, which is going to be -2.5. So down here and down here. Now, exactly halfway between the maximum and minimum on the left side, the graph crosses the x-axis. So that's at our halfway point here and at our other halfway point here. So now all we have to do is sketch our graph. I'm going to sketch it in green. So remember, it's flat, comes up, and then comes down, and then comes out again. And we're done. There's our graph.